Hey everyone, we are going to be exploring compound interest here, in which our goals will be to develop a conceptual understanding of how compound interest accumulates over time, and we'll contrast that with simple interest, which you've already learned about. And then we'll just after that find some future values of investments in which the accounts are accruing interest that's compounded. So let's dive in here. So I'm going to look at a couple examples. You can see on the screen here there are two different tables. And I'll start with the example that's towards the top, where it says that $1,000 is invested into an account that earns 3% simple interest. So I want us to be able to look at how the money is going to accumulate over time. So as you look at this table, you can see that these numbers 0, 1, 2, 3, 4, 5, all the way to t is representing the time in years. And then we're going to look at being able to determine the amount of interest that is earned within that year's time, and then also the amount in the account or the account balance. So as we've already learned about and discussed, whenever an account earns simple interest, that account grows linearly. And what that means is it adds the same dollar amount each year, right? And so because it earns a 3% simple interest rate, we should be able to compute the amount of interest that's going to be earned each year. So remember that with simple interest, we have this identity that I is equal to PRT that we can use to compute the amount of interest that's going to be accrued. So if we substitute it in for P, the principal, which is $1,000, and then 3% for the interest rate, and then any number of years for T. So if we just put in 1 for T, that would figure out the amount of interest in 1 year. If you put that in a calculator, so 1,000 times 0.03 times 1 gives you 30. So what that means then is $30 is the amount of interest that you are going to earn in the first year. So what I should probably establish here, first of all, though, is that in year 0, we haven't earned any interest yet, and the amount that's in our account is 1,000. So now what we've just established is that after the first year, there's going to be $30 of interest that we've accrued over the entire year. That then increases our balance by $30. So now we have $1,030 in the account overall. So because simple interest always adds the same dollar amount each year, because it's always based off of the original principal of $1,000, then by the second year, we would have accumulated a total of $60. So just 30 in the second year, bringing our balance up to 1,060. So what you're seeing happen is really it's just increasing by $30 each and every year when it accumulates simple interest, right? So this pattern is just going to continue. So you'll see the total amount of interest that you would have accumulated there, and then if we update our account balances, then these would be the updated accurate account balances. There we go. All right, so obviously that pattern is going to go on and develop, okay? So what we need to establish is how that is different than compound interest. So the second table down here will allow us to explore how compound interest accumulates and how it's a little bit different than just simple interest. So same scenario and conditions in that we have $1,000 that's going to be invested into an account that accrues 3% interest that's compounded. And so it's a little bit different, right? Because it's earning compound interest. So what happens with compound interest is that the interest is going to be earned off of the principal and any earned interest up to that point in time. And any earned interest up to that point in time. So that means you're always going to earn a percentage off of the most recent balance in your account. So in a little bit, we're going to talk about the frequency of compounding. So really when you think of the word compound, it's really just referring to, so when it says compounded, however, it's just referring to the number of times per year that you're going to add interest into the account. So because it says compounded annually, that just means that they're going to put interest into your account once per year. We'll talk about in a little bit what it would be like if it's compounded like monthly or something like that, okay? All right, so there's going to be no interest earned, and you're going to start off with $1,000 in your account after 0 years, right? So what's going to happen from year 0 to year 1 is you're going to take your $1,000, because that was your most recent balance, and you're going to increase it by 3%. So what that would mean is if I multiply it by 1.03, that would figure out what 103% of 1,000 is. And if you put that in a calculator and evaluate, it would tell you that you would now have $1,030 in your account. So what that means then is the amount of interest that you earn just in that first year is $30, right? So here's now where we start to see the difference in compound interest versus simple interest, because now what we're going to do is we're going to take the 1,030 balance that we had in the previous year, and we're going to take 103% of that. So if we put that into a calculator, you're going to see that we end up getting a balance of $1,060.90 overall right there. So in total, we've accrued $60.90 over the 2 years. But if you really break it up year by year, right, here you earned $30. But then in the second year alone, we would have earned $30.90. So the amount of interest that we earned in just that second year was an increase compared to the first year. So that pattern is, of course, going to continue to develop. I'll do it one more time right here, where we are going to take our most recent balance of $1,060.90 and then take 103% of it to find our updated balance. So if we just multiply our most recent answer by 1.03, then we end up getting, as our calculator shows us right here, 1,092 and about 72 cents if we round it to the nearest cent. So overall, we would have accumulated $92.72. If we take $92.72 and we subtract $60.90, the amount of interest that we gained overall over the first 2 years, that would inform us then that just in that third year, we would have accumulated $31.82 of interest, right? All right, so that's the idea and the pattern, so that's just going to continue on and on and on and on and on from there, right? So I want you to recognize some things about what I was writing in the purple right here, because this will help us understand formulaically kind of what's happening with compound interest. So you'll see right here that we took really the principal, and then we multiplied it by 1 plus the interest rate, right? Because the interest rate was 0.03, and the principal was $1,000, right? Now, if you think about the fact that this right here generated and equaled 1,030, well, then that can inform us that right here, this 1,030 is actually identical to taking 1,000 times 1.03. And if we take this 1.03 and drop it down right here, then you can see that multiplying these three numbers together gave us the answer of 1,060.90. And because right here there are two 1.03s multiplying, we could write this as actually 1,000 times 1.03 squared, because it's a repeated multiplication of 1.03. And so then I'm going to rewrite this as actually just the principal and then 1 plus that interest rate, but to the second power, right? So in a similar regard, we got this number right here of 1,060.9 by actually doing 1,000 and then 1.03 squared. And so then we're just going to multiply that by 1.03, which means that if we've got two 1.03s there and another 1.03 there, it really simplifies down to just 1,000 and then 1.03 to the third power. And so that actually just results in then P 1 plus R to the third power. So you should be able to recognize then when you look at this structure and this structure and this structure right here, that's going to really clue us into kind of a reliable formula that we can always use for compound interest, okay? All right, before I give you that though, I want us to develop just a little bit more that we need to understand about compound interest, and that's about the frequency of compounding. So you'll see on this page right here, there are 3 different examples. They're all pretty much the same in their setup in that we're going to start off with $1,000 for the principal to be invested into the account initially. And there's going to be a 3% annual interest rate. But what's going to be different in each of these scenarios here is that in the first scenario, the interest is going to be compounded annually. In the second scenario, the interest is going to be compounded quarterly. And in the final scenario, the interest is going to be compounded monthly. So what that means is when it says it's compounded annually, is it means that interest is going to be added in once per year into the account. So by compounded, it's the frequency of how often it's going to be added into the account on a yearly basis. So if it's compounded quarterly, what that means is interest is going to be added into the account quarterly, on a quarterly basis. So there are 4 quarters in a year, so that means 4 times during the year there will be interest added to your account, basically every 3 months. And so similarly, if it says it's compounded monthly, then on a monthly basis, interest will be added into your account. All right. So you'll see that the tables that I have right here all have the first row, but they are now in months instead of years, so that we understand what's going to happen when we start compounding a little bit more frequently over time. So let's consider the first scenario. So the first scenario where we are compounding annually. So what should happen in our scenario is that we should have $1,000 in our account initially, since that's our principal. So because interest is only going to be added into your account once per year, then this $1,000 balance is going to stay the same all the way throughout the year. So during all of these initial months. But as soon as we get to like the end of the year, that's when interest will likely be added into our account. And so what should happen then is there should be a 3% increase of the $1,000. So to go from 1,000 to right there, we should take $1,000 and multiply it by 1.03 to make it become 103% of itself. So what that does become then is it becomes an ending balance there of $1,030 at the end of that year. All right, so now let's talk about what's going to happen in the second scenario, where the interest is compounded quarterly, so 4 times per year, right? So when the interest is compounded quarterly, that means it's going to happen 4 times per year or every 3 months. So what's going to happen then is we're going to start off with $1,000, and that's going to stay the balance for 3 months. But then right there in the third month, it's going to change to a new balance. It's going to stay that way for 3 months, and then it's going to change to a new balance, stay that way for 3 months, change to a new balance, stay that way for 3 months, and change to a new balance, right? So you can see it's going to add interest 4 different times during the year. So here's the thing that's we need to understand is that it's not actually going to earn the 3% each time anymore. So what's going to happen is that 3% rate, it's an annual rate. And so because we're going to earn interest 4 times per year, what's going to happen is we're going to take a fourth of 3%. And what that ends up being then is it ends up being 0.75%. So that 0.75% is the amount of increase you're going to have each quarter. So what will happen then is this $1,000 will be increased in just the first 3 months, but by a rate of 0.75%. So what we're going to do there is we're going to multiply it by 1.0075 to increase that $1,000. What that then yields us is it yields us $1,007.50. Okay, after that month, or those first 3 months. So that's gonna then happen again, going from the end of, or the third month basically, to the 6th month, in which we're gonna actually take the most recent balance now, because it's compounded. So we're gonna take the 1,750 and then multiply it by 1.0075 to determine our next amount. So if I just take our previous answer and multiply it by 1.0075, we end up getting a result of $1,015, and if we round it, about 5 cents or so there. So of course that's going to continue to happen, and that then to get to the end of the third quarter, we're going to take our most recent balance of $1,015 and 5 cents, and then increase it by 100.75%. So if we update that, we're going to get to $1,022.66, almost 67 cents. And so then finally, if we do that one last time to get to the end of the year, increase it by 100.75%, we're going to end up getting then 1,030, as the calculator says, and 33 cents. All right, so what you should realize here is that the ending balance there and the ending balance there are different from one another. So it turned out that even though we earned a smaller rate of interest, 0.75% each time, because of the compounding of it, we actually ended up with a little bit more money when it compounded more frequently, when it compounded quarterly, than if it just compounded directly at 3%. All right, so we can kind of expedite our way through this one just a little bit, but it's good to do one more example just to reinforce. In this, we have that we're compounding monthly. So if it's compounding monthly, what should happen is the 3% annual rate is going to get divided by 12. And what you end up getting then is you end up getting 0.25% increase each month. So what's going to happen then is if we start with our $1,000 principal, we're going to increase directly in that first month the $1,000 by 100.25%. So if you take your $1,000 and make it become 100.25% of itself, we end up getting a balance of $1,002.50. So then we would take that most recent balance of 1,250 and then multiply it by 1.0025, and that's going to then give you $1,005 and not quite a penny yet. So kind of $1,005 on the dot there. But if we then multiply it one more time, you can see that then we start to get a little bit above 1,750 because there we get about 51 cents, right? All right, so that pattern's going to kind of continue. So ultimately, if this continues all the way through, what's really kind of happening once we get to this end amount is we're just taking the $1,000 and we're continually multiplying it by 1.0025, but really 12 times because that's the number of months within that year. So if I put that in my calculator, just 1,000, 1.0025, and then to the 12th, we end up then getting $1,030, and if we round it, about 41 cents as an ending balance right there. So if you do compare the 1,030.33 when it was compounded quarterly, and then the 1,030.41 when it was compounded monthly, there again you can see that when it compounded more frequently, 12 times per year versus 4 times per year, compounding more frequently resulted in a higher ending balance in that same amount of time. All right, so I will now in just a little bit give you a formula that will be really useful to use when we're dealing with compound interest. Before I do so though, I want to make sure that we understand some common different compounding frequencies. So we will oftentimes see in scenarios where interest is accumulating compounded blank. And so I want to delineate each of those frequencies. So some of those frequencies that we will definitely encounter include an annual frequency. So on an annual basis, annually means once per year. Another common one that we'll encounter is semi-annually. So semi-annually happens twice per year, every 6 months in which interest would be added to your account. Quarterly is another common one, which we saw just earlier. That's 4 times per year, so every 3 months. And then more frequently than quarterly, we oftentimes will see on a monthly basis, which is 12 times per year. And weekly is another common one. There's 52 weeks in a year, an extra day or an extra 2 days if it's a leap year, but for the most part, 52 is often used. And then daily would kind of be another common one. So we generally will use 365 for the years where there isn't a leap day happening. So those frequencies should be familiar and comfortable for you. So to help us develop this idea of the compound interest formula, I want to use the example that we were just working through right here to help you understand how the compound interest formula is working. So breaking this apart right here, what we really did is we actually took this $1,000 and then we took 1, and what we added to it is we added the 3% but divided into 12. So what you should recognize is that this fraction right here, when it divided out, it gave us 0.0025, that 1/4%, that then would add with that 1 to equal this number right here. So generalizing this, we actually took the principal and then 1 plus our annual interest rate, and we divided it by 12. And so I'm going to introduce a new variable that we haven't seen here yet. I'm going to use n to represent the frequency of our compounding. And so it turns out that that n number, 12, is actually the n number that we see up right here. And so that n number would correspond also to be in the exponent right there. So there's just one more variable, t, which would be the number of years, that gets applied in the formula as well. But ultimately, what I've just given to you right here is the formula that can be used for compound interest. So I'm going to write that here on the next page, that A is equal to principal, and then in parentheses, this quantity of 1 plus r over n to the nt is the formula that we can use for compound interest. So just organizing what all of these variables all mean, A is just going to stand for the account balance, so how much money is in your account at any given time. And then P is going to be the principal balance in your account, so how much money you initially invested into the account. And then R is going to be your rate of interest, but on an annual basis, so it's your annual rate of interest. Remember that you should always express that in its decimal form. And then N is going to be the number of compounds, so the number of times interest is added into your account, that's what that means, annually. Meaning we're only looking at the number of times in a single year that interest is added into your account. So if it was daily compoundings, then we would use 365 for N. If it was quarterly compoundings, then we would use 4 for N. And then finally, T is going to be the number of years in which you have the money invested into an account. And remember that it's always in years. All right, so I want to take a look at a scenario where we can use this formula. So this example right here says we want to know what is the amount of interest earned after 30 months' time on a $45,000 initial investment in an account that earns 0.84% interest that is compounded daily. All right, so we can use the compound interest formula to do this because we know that the account does accrue interest that is compounded on a daily basis. So to figure out the future value of this account, we would want to put in the principal, and what we know is there's a $45,000 initial deposit, so we would use $45,000 for that principal, and then our annual interest rate is a 0.84% rate of interest. You would need to move that decimal over a couple spots, which would bring it to then become 0.0084. But then that needs to be divided up based on the number of compoundings. And what we see here is that the interest compounds daily. So the bank or whoever holds the account is putting interest into the account on a daily basis. So that is 365 times per year. So you would need to use 365 for that value of n. So you actually need to also use 365 in the exponent since n shows up in that formula a couple of different times. And then that 365 is going to get multiplied by the time that you're going to keep the money in the account in terms of years. So we want to know the amount after 30 months' time. So we would need to convert 30 months into years. So since there are 12 months in a year, we would write that as 30/12. It does simplify to 2.5 since 30 months is 2.5 years. But ultimately, this is just something that you could, type in a calculator and then know how much you're going to have in your account at that time. So I'm going to type that in right here. And then close off that parentheses, and then I'll exponentiate this and have 365 multiplied with 30 divided by 12. And then it comes up with this value that we see right here. So $45,954.98 if we round it to the nearest cent and round it down. All right, so that right there is going to give you how much money is in your account after those 30 months. We didn't really answer the question, though, because the question was asking for what is the amount of interest that was earned, and the amount of interest that was earned should be how much like you've added to your principal. So since we started at $45,000 and we ended at $45,954.98, we want to subtract. So that would tell you then that the amount of interest that you accumulated would be $954.98, since it's the difference between the starting and ending balances over those 30 months. All right, one last thing that we will hit here to close up compound interest is to kind of explore the following idea. So I want to assume that we have a scenario where let's say that we start with a principal, and let's just say that we start with $1, okay? And then let's assume that we have an interest rate that is 100%, okay? So I want to look at how our money is going to grow in different scenarios in which we're going to compound at different frequencies. So let's consider on an annual basis. So if we compound annually, right? So based on the compound interest formula, we can put our principal of $1 and then always 1 plus. So our interest rate is 100%, but as a decimal, 100% is just 1. And if we're going to compound that annually, annually means once per year. So we would put a 1 on the bottom of that fraction. And so then we would raise this to the 1 times, and now I'm going to try to figure out how much is in our account after 1 year's time. So it might be a good idea here for me just to write out the compound interest formula just for reference so we can kind of correspond all of these values here. So we have the principal right here, which is $1, so that's why we have $1 right there. And then we also have the interest rate. So that interest rate is 100%, and that's what we wrote right there because 1 is 100% as a decimal. And then because of this one right here, that's the compounding frequency, which corresponds to the fact that we are compounding annually, which is once per year. So that's why we have those ones. And then finally, I put this one right here because that's going to correspond to T, because I'm just going to figure out how much money we're going to have after just 1 year's time. All right, so now that I've clarified how I've set that all up here, let's evaluate this in a calculator. So putting this into a calculator, we end up getting 2. So we end up getting $2 if our interest compounds annually, right? So what if we increase this to say like go on a semi-annual basis, right? So semi-annually then, well, we're going to keep the same principal of $1, and this is always 1. It's still 100% interest, but now we're going to divide it by 2 because it happens twice per year in which we're going to add interest. But I'm going to put a 2 right here, and then let's still figure out how much money we're going to have after 1 year's time. So now if we make these adjustments, we end up doing 1 plus 1/2. And that's going to be raised to the 2 times 1. I didn't type that in right, so let me type it in correctly. Okay, that's the correct typing of it. It gives us $2.25. So as we expected, when we compounded more frequently, semi-annually, we got a lot more money, right? So I really want to step this up a little bit more in terms of frequency. So let's jump to, let's say, on a daily basis. So daily means 365 times per year, right? So on a daily basis, the amount that's going to be in your account will take your $1 starting balance, 1 plus 100% interest, but daily means 365 times, right? So then we put 365 there and times it with a 1 for 1 year's time, and then let's evaluate what we're going to get. So what we end up getting there is we end up getting $2.71 about if we round that off. So we could even go further than this. Like, interest could compound more than just once per day. It could compound by the hour or by the minute or something like that. So if we go, let's go by the minute. So by the minute would look something like this. So it does turn out that there are 525,600 minutes in 1 year. So you would add interest into your account 525,600 times in that year. So what we would want in our exponent then is 525,600, and then times it with 1 to figure out how much we'd have after 1 year's time. So in our calculator then, we would end up getting about 2.71 again. So it's not really all that different from daily, right? So we could like try to compound this like a whole bunch. So like, I'm just going to make something up in the calculator right here. So let's say that we did it like, I don't know, that's like 1 billion. So let's say we added interest into our account 1 billion times per year. Then what we'd end up getting is, if we did 1 billion times per year, you can see it's still like 2.71, right? So it doesn't seem like it's tending towards infinity. It ends up like converging to a particular number. So if we were to actually do this like infinitely, could we do such a thing? And it turns out that there is such a thing, that you could actually add interest literally every moment of existence. What that would do is would chop up your 100% interest rate into just the smallest infinitesimal amount of increase each moment of existence of time. But if we were to do such a thing, it actually converges to a very special number, and it grows at the rate of the number that we call E. It's actually a number that you can find on a calculator. So if you look on the calculator that I have right here, if you look on the right-hand side and find the division symbol, find where that division symbol is. It's a gray button. And you look above the division symbol, there's a blue letter E. So if I type the second button, which is the blue button, and then I push the division symbol, there's E right there. And then if it equals, it tells you that E is 2.7182818,285, but the decimals do go on forever. So it's kind of a number like pi, where the decimals go on forever and will never repeat. E is kind of a special number like that. So what I've just kind of helped develop right here is the idea of having an account where there is compound interest, so it grows off the most recent balance in the account, the initial principal plus any earned interest up to that point in time. But if it earns continuous compound interest, continuous means that it earns interest every moment of existence. And that requires just a little bit of a different formula than what we're working with up here, because this formula up here only works if you're adding interest a countable number of times per year. So if you're adding interest quarterly 4 times per year, or if you're adding interest like 1 billion times per year, then you'd use that formula. But if you're learning interest literally every moment of existence, then you have to use this formula here for continuous compound interest. So this formula here is going to be amount equals the principal, and then it would multiply with the number E, that's not a variable, the number E raised to the RT power. So we know what most of these things stand for already. We know that A is going to be the account balance in your account, and P is going to be the principal, the starting amount that you have in your account. And then E is just a number. E is actually called Euler's number. Euler is just a famous mathematician. So what you should know about Euler's number is that E is approximately 2.718 and goes on from there. You should at least know that, but when you're doing your computations and stuff, it's just a button that you could find and use on your calculator and use the number E. So most calculators are going to have a pi button and an E button. If not, then you can use 2.718 just to approximate E. And then R is going to be your annual interest rate. And then finally, T is going to be the amount of time in which you're going to keep the money in your account. Remember that it's going to be in years. All right, so I'm going to walk you through an example where we can use this continuous compound interest formula. So it's actually very similar to the question we just worked through a little bit before, because we want to figure out the amount of interest that's earned after 30 months, $45,000 to start with, earns 0.84% annual interest. The only thing that's different, though, this time is that it's compounded, but it's compounded continuously. So when it's compounded continuously, then you're going to have to use this formula right here. So if we plug in everything, the principal, $45,000, and then you'll write E just as it is, because E is just a number, right? Like when you write pi, you'll just write pi for 3.14. So when we write E for 2.718, right? And that's going to be raised to the power of RT. So you'd want to make sure that you move the decimal over a couple spots for that interest rate. So we take that 0.84%, move the decimal over a couple spots to become 0.0084, and that's going to times with the time in which we're keeping in the account, which is 30 months time. Remember that time, though, is always in years, so you'd want to change that to become 30/12, and then we can evaluate what this is going to be. So if you put that into a calculator, $45,000, and then remember where I found E, it's above the division symbol, so second divide, and then you raise that to the power of 0.0084 and multiply it by 30/12, and then that's going to end up evaluating out to become $45,954.99. Doesn't quite make it up to the $55 mark there. So that's going to give you that balance in the account after that given time. We did not directly answer this question here either, because it's asking for what is the amount of interest that was earned after 30 months. So again, similar, if this was the starting amount in the account and this is the ending balance after 30 months, then we can subtract those two quantities to find the amount of interest. So you'll see that the amount of interest that you earned would then be $954.99 over that given time. So one last thing that I just want to point out here is that you should understand that as you compound more frequently, so if you go from compounding annually to semi-annually to quarterly to daily per minute, you should see that you are going to always end up with more money when you compound more frequently. So in this scenario right here, where we compounded daily, we ended up getting $45,954.98. But when we compounded continuously, which is more frequently than daily, we ended up with $45,954.99. I know not a huge difference because it's only a cent higher, but you should recognize that always when you compound more frequently, it will result in a greater amount of growth in your account.